Hello, everyone. This is Dr. Jenkins, and welcome. Welcome to your next video. Here is our first official chapter. So I know we talked about the scientific method, which is really important. But now we're going to begin to talk more specifically about sports nutrition, which, after all, is the name of the course. This first chapter is actually really important because it lays the foundation. So we're going to introduce some terms and the nutrients and set us off for a good semester. Here's our outline. Let's just dive right in. Okay, so when talking about nutrition, there are 6 total nutrients. There's 6 nutrients that we really care about: carbohydrates, fats, protein, water, vitamins, and minerals. Make sure you know all 6 of those: carbs, fats, proteins, water, vitamins, and minerals. Additionally, we need to know how they are separated. We can see the top 4 here are considered to be macronutrients. And it's not because they're bigger in size, it's because our body needs them in larger amounts. You know this. We need to drink a lot of water. We need a lot of carbohydrates. On the other hand, the vitamins and minerals are considered to be micronutrients because we need them in lower amounts. Now, this isn't to say that vitamins and minerals are less important. All 6 of these nutrients are really important. It's just that we don't need as much of it in order for our body to function properly. Okay? Excellent. So make sure you know those. I'm going to move along kind of quickly because the beauty of this is you can pause the video if you need to, or you can rewind it a bit if needed. Now, it's important to state the obvious. It's easy to think of food, well, it tastes good, so we just eat it. But there's actually a reason why we absolutely need food. It's not because it satisfies our taste buds. I mean, that makes it feel good in our mouth, but the reason we actually need food largely is because those nutrients provide energy, particularly carbohydrates and fats, and then structure. So our protein helps us with structure. So what I'm saying is, the reason that we need food is because it gives our body energy and structure. Think of it like a car. If you don't put gas in a car, it's not going to go. If you don't give the human body fuel, carbs, sugar, if you don't give the human body fuel, it's not going to go. So that's why we really need to eat these nutrients, because our body needs them to produce energy, to give us structure. Obviously, it's just fun to find these crazy pictures. If a car doesn't have the right structure or fuel, it will break down. Even though it takes a while, it can absolutely happen with sports. If you don't have the right fueling, you can really end up in trouble. Okay, so here we go. We're going to talk about each of these nutrients: carbohydrates, fats, protein, vitamins, and minerals. And to introduce them, we're going to talk about the basic structure and the function. I've gone ahead and put the things that you need to know in red. It would be ridiculous for me to ask you to know everything. So to help you really narrow things down, make sure you know what's in red. Now, we're going to have whole chapters on these nutrients later. We're going to have a whole chapter on carbohydrates, an entire chapter on fats, etc. But it's still worthwhile for us just to introduce them. So our first nutrient to discuss is a macronutrient, because we need it in large amounts. Our good old friend, carbohydrates. You can read about the structure. I've got a picture here of the molecular structure, but you do not need to know that. What I would like you to know is we break up carbohydrates by what we call simple sugars and complex sugars. So you should know that. We have our simple sugars and our complex sugars. The simple sugars include monosaccharides and disaccharides. I mean, break the word down. Mono means one, saccharide means sugar. So a monosaccharide is a molecule that is just one sugar, like glucose. Glucose is an example of a monosaccharide. You're going to need to know that anyway later, so let's just get it out there now. On the other hand, a disaccharide, as the prefix suggests, is a two-sugar molecule. So it would be like two of these identical stop sign shaped things side by side. And then a complex sugar is 3+ sugars combined together. And we call them polysaccharides because poly means many. Here's a monosaccharide, one sugar like glucose. Here's a disaccharide. It's got two sugars, 1, 2. The example I'd like you to know for disaccharide is sucrose. And what sucrose is table sugar. So if you have sugar packets to put in your coffee, that is sucrose. And then we have 3 examples of polysaccharides. Now you can see here it's actually 10+ sugar. So if I go back, I was being a little simplistic when I said 3+. Let's get things right. 10+. I mean, it's just a lot. Because actually, most polysaccharides are tens upon tens or hundreds of sugars. Make sure you know these 3 examples of polysaccharides. Starch, that's what's in the potatoes that we like so much. You know, potato chips, french fries. Fiber, it's in granola and Mueslix, helps to move things through our GI tract. And then glycogen, which we're going to discuss later. Glycogen is stored glucose, stored sugar. But just for now, I'll be able to list these 3 examples of polysaccharides. You've seen these before. So glucose, if you're a distance runner, maybe you've eaten one of these goo packs. I know for the Ironman, I did. It's glucose, which means it's only one sugar. Very easy for our body to digest and absorb because it's so simple. I mentioned sucrose being table sugar. Glycogen. Glycogen is stored glucose, fiber, and then starch. Let me go. So if you look at some of these slides, it does have the functions, but I'm going to talk about the functions in a couple of slides. So for now, we're just talking about the structure. Okay? So let's review. We'll talk about function later. Structurally, we have simple sugars, either mono or disaccharides, and complex sugars, which are polysaccharides. An example of a monosaccharide or one sugar is glucose. An example of a disaccharide or 2 sugars put together is sucrose, which is table sugar. And 3 examples of polysaccharides would be starch, fiber, and glycogen. This is just to give you examples, you know. Glucose, hey, it's in there. Sucrose, hey, it's table sugar, right? Just to give you some examples. It's one of my favorite cartoons. The fruit being weighed in front of its other fruit peers. My weight's none of your business. All right. We're going to cover this much more later, but I'm introducing these things, and we're going to see them again. So it's going to make your life easier because we're going over things again and again. When we talk about our overall diet, guess what? Somewhere between 45 and 65% of our entire diet should come from carbohydrates. You should know that range. We'll talk later about what AMDR stands for, but just know right now, Of our entire diet, somewhere between 45 and 65% of it should come from carbohydrates. I give you some examples in grams, but you don't need to know that. So we need a lot of glucose because it's a lot of carbohydrate because it's a main energy source for us. All right, speaking of functions, we already know, probably, carbohydrates give our cells energy, like fuel to a car. I want to be a little bit more specific because, and the wording is a little bit funny, but I think over time you'll get with me and you'll understand. Carbohydrates are, some might call them immediate or short-term energy. Meaning, this is what our cells go to first. What our cells go to first. Really important. Glucose, carbohydrates, it is our cells' first energy source. Another interesting thing about carbohydrates, it is a central nervous system fuel. So it gives energy to the cells of our central nervous system. This is important to talk about because what this means is our central nervous system can only metabolize carbohydrates. It cannot metabolize fats or protein for energy. So getting the carbohydrates up to our brain cells is really important. And our brain cells can only metabolize sugar. All right, let's talk about lipids. We're going to talk about 3 categories. We can't just say fats because we need to be a little bit more specific. So here I've broken down 3 main categories of what we call lipids. Here's the structure. You don't need to know the molecular structure. I just like to include a picture so you can see how it looks different from the carbohydrates. The carbohydrate, remember, had that hexagon or stop sign shape. Fats look very different. Okay. Our 3 categories that you need to know are triglycerides or dietary fats, phospholipids, and cholesterol. Okay, number 1, our triglycerides. This is what you think of. When someone says to you fats in terms of nutrition and diet, you're thinking about the triglycerides or dietary fats. This is the Big Mac fat, the Reese's Peanut Butter Cup fat. And it's delicious, isn't it? Phospholipids, as we're going to find out later this semester, these are really small lipids. They kind of look like this, look like little sperms almost, or little pegs, and they line up in a line with the tails facing each other. It is what makes up our cell membrane. So you may not have realized it, but all of your cells, muscle cells, nervous cells, kidney cells, lung cells, skin cells, liver cells, everything, all of our body cells, microscopically, if you were to look at it up close, the outer membrane of our cells is made up of these specialized fats called phospholipids. Lastly, I just took a drink, I apologize. Lastly, we have a 3rd category. You may see it called different things, echinosoids, derived lipids. I'm going to simplify it as cholesterol, which we'll talk about later. All right, so make sure you know the 3 types of lipids and a little bit about them. Triglycerides are dietary fats. This is the Big Mac fat. Phospholipids are a type of lipid that make up our cell membrane. Cholesterol is a 3rd type of lipid. In terms of functions, I'm going to give you 2 functions. The one function up here, we utilize fat for energy. But unlike carbohydrates, it's what our cells turn to second. Our cells will turn to carbohydrates first for energy because they're not able to burn fats right away. But when they can, they'll start to burn these triglycerides. And our body likes to burn triglycerides. I want to point out that ultimately, we're burning a carbohydrate fat mixture. So it's not true to say that our cells are only burning glucose here, and then all of a sudden they start burning only fat. That's not true. Almost always, our muscle cells, for example, they're burning some kind of mixture. But if it's a short activity, let's say the 100-meter sprint, what's the world record for 10.49 seconds or something? Probably take me 30 seconds. I don't even know. So if we're doing a sprint that's 10, 20, 30 seconds, well, we're obviously going to be using primarily carbohydrates and a very small amount of fats. But as we exercise for longer in duration, we start to burn more fat. So a marathon runner, for example, is going to be burning a whole lot of fat. Sure, they'll be burning some carbs too, but they'll probably be burning more fat. So that's the first function I'm going to talk about of these lipids, our second source of energy. And then also, as we already have discussed, some of our fats make up the outer membrane of our cells. All right. You can see a trend here. I talked about how much of the diet should come from carbohydrates. That was 45 to 65%. Well, now we're talking about fats. And of course, we're going to be talking about the triglycerides. Of our daily diet, we should be eating about 20 to 35% of fat. Know these numbers, right? 20 to 35% of our diet should come from these triglycerides. All right, our third macronutrient, we did carbs, we did fat, now we're doing protein. Structurally, something that's unique about protein is that it contains nitrogen. If you go back to the other slides and you look at the molecular structure, you'll see carbon, you'll see hydrogen, you'll see oxygen, but you will not see nitrogen. So this is one thing that makes proteins unique. Here's the nitrogen right there. And in the protein chapter, when we get there, we're going to see that it is that nitrogen that makes protein what it is. It makes it difficult to deal with sometimes, but it is what it is. Structurally, what I'd like you to know is every protein in your body or from food is made up of amino acids. So every protein is made up of these building blocks called amino acids. Sometimes a protein will have only a couple amino acids joined together. Other times you have a complex protein that has hundreds, maybe even 10,000 amino acids. There are only 20, and I'd like you to know this, there are only 20 different amino acids that we know of, which means that every protein in your body, every protein in a food that we eat, is some combination of those same 20 amino acids. And it may not have all 20. Not every protein has all 20, of course. Very few do. But that's the collection it has to choose from. So I've just given you some examples of what protein can look like. You don't need to know these. Sometimes a protein can be a long, relatively linear chain of amino acids, like insulin. Sometimes it'll be a very complex structure where proteins form these globules, and then those globules clump with other globules, very complex protein like hemoglobin. Sometimes they line up in these horizontal rows in muscle. So proteins can look very different. Of those 20, so we just finished saying there are 20 total amino acids, and every protein is some combination of some or all of these 20 amino acids. we're going to further break it down. Of the 20, 9 are considered essential, and I would like you to know that. 9 are considered essential because it is essential that we get them from our diet. On the other hand, we have the remaining 11 are considered non-essential, which means it is non-essential to get them through food because our body can make them. That's pretty awesome. I mean, I get excited, but I get excited about a lot of things with science, so it really isn't that surprising. So these 11 amino acids our cells make for us. Our cells are little amino acid producing factories. It's great. But it is only these 11 that our cells can produce. The other 9 our cells cannot produce. And that is why we have to get them through food. And they're considered essential. I've given you the list of which amino acids are essential and which ones are non-essential. You do not need to know them specifically. Excellent. This is just a reminder. What we're going to find here, let's see. Yeah, I'm going to go back. Just like we did for carbohydrates and fat, here is a recommendation of what percentage of our diet should come from protein. Now, let's just review because I think this makes a pretty important point. We talked about somewhere between 45 and 65% of our diet should come from carbs. The dietary fats or triglycerides, we said somewhere between 20 and 35% of our diet should come from fats. And that leaves protein. And you might be surprised that this is what we need the least of for most people in comparison. And that surprises a lot of people. And I can understand. You know, everyone talks about the importance of protein, and it is really important. So it's easy to think that, well, if protein's so important, I must eat a lot of it. But what that perspective is missing is that our body can make over half of the amino acids that we need. Our body cannot make carbohydrates and fat in the same way. We've got to get all of our carbohydrates and fat through diet. So, you know, I've heard students talk about me as a protein hater. And that's not true at all. We need protein. But I'm just giving you the science. Because our cells can make over half of them, we don't need as much through diet. And in fact, what we're going to talk about later, if we bring in more protein than this, it's really hard for our body. Our body cannot store protein in large quantities. It is difficult to break down protein and excrete it through the urine. So if we bring in more protein than we're able to store and or break down and excrete, what is our body going to do with it? That excess protein gets turned into fat. This is not going to be on the test, but I'm just making a point. All right, you can read about the complete versus incomplete proteins. You do not need to know this yet. Proteins are very prevalent in our body. Very, very prevalent. I'm going to give you 3 functions for protein. Trying to think about how I apologize for the pause. Let me write up here. I'm trying to simplify it. Hopefully it's working. One function of protein is structure. And this includes, protein gives us structure for our muscles, but that's not it. Hair, nails, skin. I'm just going to pause this for a moment. Yes, I'm recording a video, but do you need something right now?
I'm so sorry. I thought you were free from 5 to 6.
Well, I usually am, but I'm recording a video. I'll be done probably in like 20 minutes.
Sure.
So we'll still have some time before class. Is that okay?
No worries.
All right. Sorry about that, everyone. So for our structure, protein helps us to give structure to muscles, hair, nails, our skin, ligaments, tendons. These are all things that we use protein for. But a less known function of protein is that it helps to form chemicals. And this is one that maybe isn't as well known, but it's oh so true. Look at all these things. A lot of important chemicals in our body, enzymes, hormones, neurotransmitters, antibodies. All these chemicals are structurally made up of protein. How about that? And then our third function here is that it is our last resort for energy. So we can burn some protein for energy, but we don't want to burn too much because it's really not what it's designed for. Typically, we want to be burning maybe 10%, maybe as high as 15% of our energy source coming from protein, but that's it. All right, water. So water is another macronutrient we talked about. We have a lot of it. Here are some functions of water. Make sure you review these. Water can help us with protection. It is a universal solvent, which means that things can dissolve in it. And it is used in chemical reactions. There's more. I'm just giving you a little bit of an introduction. Okay, let's talk about these micronutrients. Remember, we have vitamins and minerals, and they're considered micronutrients because we don't need as many of them in our diet. It's not that they're less important, it's just that we don't need as many of them through our diet. We're going to keep it simple, and all we're going to say is that these vitamins and minerals act as a supporting cast. Or another way of saying it is that they are helpers. We have entire chapters on this later this semester, but vitamins and minerals tend to have indirect actions. We're not going to burn a specific vitamin for energy. Now, it's true, the B vitamins can help our cells burn carbs or fat for energy, but it's an indirect. But for now, let's just leave it as these micronutrients have a helper role in the functioning of our body. Okay, I'm going to take a pause, and I'll be picking this up with video number 2 for this chapter.